and welcome to another episode of This Is My Architecture. I'm Aarti from AWS, and joining me in Mumbai today is Francis from CleverTap. Francis, thank you for joining us today.
Thank you for having me over, Aarti.
So Francis, tell us what CleverTap does.
CleverTap is an ML-powered customer lifecycle management and engagement platform. We are at the forefront of analyzing granular consumer behavior and then completing the loop in real time with meaningful omni-channel engagement. On interesting days, we ingest about 10 billion data points.
That's a lot of data points. I'm sure it also comes in with a number of challenges. So what are we going to discuss today?
So there's two things to this, Aarti. There's the platform itself that supports all these users. It helps ingest all this data and then enables omni-channel engagement. But there's also this whole AWS stuff that powers the platform. How do you sort of provision, how do you maintain across the life cycle and then reproduce all of this infrastructure? That's what we're going to talk about today.
Okay, so why don't we dive into the architecture?
So everything for us begins as a branch in Git. It could be the smallest change that to a new feature. All of that starts as a branch. What we do is once someone's worked on it, they would take that, they would create a PR in Bitbucket. That pull request triggers an API gateway via webhook. The API gateway in turn triggers a Lambda function, and the Lambda function downloads the whole repository from Bitbucket.
Okay, so once that I'm assuming that gets into S3 here, what files are these? Are these repositories of your templates or code configs, or what files are these?
Yeah, so what we've got from Bitbucket now and zipped, put it into S3 is about 200 odd CloudFormation stack templates that we've zipped and put into S3.
And why do you zip it?
You need to zip it because that keeps CodeBuild happy. They need a zip file as an input artifact. So CodeBuild then gets triggered because there's a change in S3, an object change. CodeBuild then sort of figures out files that have changed and pushes them to S3.
Okay. How do you know files have changed when you push them to S3 here?
We kind of need to detect change. Otherwise, what would happen is that all these code pipelines that depend upon files in S3 would start triggering and they would just run a change without anything really being in there. So what we do is we download everything from S3 first in the code build phase. We detect change by just doing a sum. And then just the ones that are changing, those are the ones that get uploaded into S3. Once they are in S3, a code pipeline automatically triggers, and a code pipeline then would go and would apply a CloudFormation chain set on a stack. And that's how a whole change is deployed in our environment.
Okay, you mentioned about the change sets being applied. Are there any manual intervention of approving these change sets?
So there are some stacks that do not need any manual intervention in the code pipeline phase. But there are stacks which are pretty core. They have stuff that should not be changed on a daily basis. For those stacks, we have like a in-between phase where you see the change set, you review it once more before saying apply, and that apply causes it to then sort of get applied to CloudFormation.
Okay. From your operations team perspective, given that you've automated the entire deployment phase here, what access do they have to the console itself?
So that's interesting. What we've been able to achieve with all of this is 100% read-only access to the AWS console. No one has write access to the console. Every time you need to make a change, no matter how small or big it is, you have to go through this whole pipeline, and this ensures that we've been able to manage every single change and document it.
I think that's also neat because now as you plan to deploy in multiple regions, you have this process in place with the entire automations, so you don't have to go step by step in other region deployment processes.
Yes, so that kind of gives us an edge. We run parallel deployments in AWS regions. This is because customers are bound by laws within their region that the data can't leave the country, which is what this allows us to essentially orchestrate very, very easily. So if there was a new region that we have customers in, we'll be able to pull all of this, put the whole stack together, in a few hours, yes.
Okay. Anything you're looking in the future in terms of enhancement? I know we talked about some manual intervention steps. Any other thing that you are planning to improve?
So yeah, the manual thing is kind of irritating because we have to go now and suddenly look at all the regions where we are operating and go manually look at it and sort of say, this is, I approve this thing. Instead, I would like it to just show up right at the PR. So the minute a PR is created, if you could just get the change set back here, it not only shows you the code that's being changed, but also the resources that are going to be affected with this change. And if you can just see it here, you know for sure that it's going to go through, and you can take out that manual phase there and let all the deployments just flow through.
Okay, that's great. Francis, thank you for sharing this architecture. Really neat mechanism of how you automate the entire process. Especially, I like it when folks don't have access into the console. The read-only console access is great. I'm sure your auditors and compliance folks are really happy with this architecture.
So yes, one of the motivations behind this is to also keep our auditors happy. They can see every single change. I can tell them, here's a change log. You can do whatever you like. So that's, yeah, 1 for us, 0 for the auditors.
Thank you for sharing this architecture with us today. And thank you for watching. This is my architecture.